we start counting from today, 24th October. All right. Next, I need to give you a homework assignment number 2, basic queries practice. So you need to do that assignment before the midterm. So that's why I said 2 weeks from Wednesday. I plan to post that assignment by Wednesday. I try to do it tomorrow. So hopefully by Wednesday, you will see that assignment, homework assignment number 2. Then you need to have a little more than 1 week to complete it. Okay, 1 week. So 1 week from Wednesday, that is November the 2nd. All right, November the 2nd. But here I like to set the deadline to November the 4th, Friday. So you have more than 1 week to complete it. November the 4th, Friday. So I can use the weekend to complete the grading. Weekend. All right. So I have at least 2 days to complete the grading. But after that, on Monday, so Friday, November 4th, Monday, I need to explain some of the questions in that assignment. In that assignment. All right. Then Wednesday, November 9th, our midterm. But for homework assignment number 1, I will talk about that on this Wednesday. So this Wednesday, I try to finish grading of homework assignment number 1 so I can explain questions this Wednesday. All right, so then November 7th, Monday, I will explain homework number 2 questions. So then 2 days after that, Wednesday, we will do our midterm. All right. And you try to arrange your schedule. You need to come to the classroom to do it. All right. For those students, if you feel the time, our classroom test time, not convenient, you need to make an appointment with the test center. All right. The test center, you can use, let me see. Wednesday, probably different time, right? So I give you also option Wednesday, different time. Okay. Wednesday, different time. Because this late, if you feel not good for you, you can do it a little earlier at the test center. Not here, test center. Wednesday, Thursday, Friday, these 3 days, you try to find one of the 3 days that you feel convenient for you. You make appointment with the test center. So then I will send a PDF file to the test center. So you will do that. The same way, the same rule. Oh, regarding the rule, I don't know if I talk about that or not. Here, let me just repeat it if I didn't say anything. Open notes, open book. All right, open book, notes, open book. Regarding for the notes, still, you do not have to print it out, because our notes basically electronic notes. You do not have to print, because then, thick, very thick paper. So if you really want to do that, that's okay, but I do not require you to do that. That means you're allowed to use computer to access electronic notes. You're allowed to use laptop, electronic devices to access electronic files. Right? But you cannot use search engine and communication software. No. No. But only study notes, okay? Only use your electronic devices to study notes. Yeah. No communication, no search engine actions. Yeah. So those things I treat as violations. The same rules for those students working in test center. Test center, I will tell, people there these rules. Okay. Yeah. All right. Just try to make your plan. We will have a little more than 2 weeks, 2 days, more than 2 weeks from today. Yeah. And prepare for this midterm test. Okay. All right. Yeah. So any question about midterm? Yeah, let me know. Yeah. Oh, I will post this information in the announcement. Yeah. So to make sure everybody can, be aware of it and make your plan. Yeah. All right, so let's start our plan today. I will do explanation for 3 questions in those 3 quizzes. Yeah. If I have a little more time, we have part A of module 5, several slides left from part A of module 5. Okay, all right. Homework assignment, number 1 grading, I try to give you back by Wednesday. Wednesday. So we complete homework assignment 1 and start homework assignment 2 on Wednesday. Yeah. All right, so let me start here. Yeah. Part B, yeah, just review, okay? Yeah. But review part 1. Yeah. Wednesday, we will do review for midterm part 2. Yeah, mainly homework assignment question 1, yeah, number 1, yeah. All right. B.1, explanation for questions in actually selected questions. Yeah. I do not need to explain all 10 questions. I just select some relatively hard questions. Because some of the questions, the answer pretty straightforward. Yeah. If you find it somewhere, that's all you need. Yeah. But for some of the questions, yeah, even you answer correctly, yes, no, yeah, you like to know why. Yeah. So we mainly will work on that part. Yeah, why it is correct. Yeah. All right, the first question, question number 4 of quiz 1. Which of the following programming or authoring? Yes, because HTML, oh, let me change the pen color. Yeah. All right. Yeah, because here we know if we want to talk about it precisely, we like to use the authoring, not programming. Programming, we're supposed to do logic, reasoning, right? A lot of logic things we need to do. But HTML, CSS, we just do static things. Yeah. No logic control things there. Yeah. All right. Handle the dynamic content. Yeah. Here, the question, yeah. Although we know the answer is JavaScript at the client side, right? PHP at the server side. Yeah. But here, I may like to talk a little bit about the CSS because some students know a little more, yeah, about CSS. We can do a little dynamic things. Yeah, we can change some properties of CSS rules in some dynamic way, you know, animation, you know, a little bit. Yeah, but that part, very little, okay? The most part of CSS still static content. Yeah. Describe information, presentation, rules, using some special properties. Yeah, basically static. Yeah. But the newer version, CSS, newer version, some small dynamic features added, but very little. Okay, very little. Yeah. All right. So that means, yeah, you should not choose CSS as your answer, but choose JavaScript. So we know, so that is the mainly dynamic content. It is used to manipulate dynamic content. Yeah. All right. Second question, question number 5. Since the SQL language is an industry standard, any SQL statement, any SQL statement, okay, can be executed by all the DBMS that support SQL. If some of the students, yeah, so if you didn't pay attention to one important part in the class, remember the SQL, we have 2 parts, the core part and extension part. Right? Quite special, the core part, right? The core part, that's standard, all right? Yeah. SQL standard, yeah. All the DBMS vendors, they need to support that core part, no exception. Yeah. But extension part, then that's quite different. Yeah. Then different vendors, they do this part differently. Okay, yeah. So not standard. This part not standard. Right. But in this statement, now, if you do not have this background, so you cannot see the difference here. Core and extension, you cannot see. Yeah. Yeah. But here the fact is, when you need to change DBMS, many SQL statements will be changed. And that conversion work is pretty difficult. Yeah, that conversion work. That kind of conversion, yeah, pretty hard. Pretty hard. Yeah. Okay. Yeah. Here I hope I can find some examples. Yeah. So let me try from my old notes. Yeah, I can probably find an example change from MySQL to Oracle. Yeah, yeah, but yeah. Last time I mentioned that there is one keyword, limit. Limit available in MySQL. Available. Yeah. But not available in Oracle. not. Okay, yeah. Because we know limit quite so convenient. And the length function, remember, I also mentioned last time the length function. That is a special function for MySQL. Length function. You find the length of a string. Length. Okay, length function of a string. So very convenient in MySQL, yeah. But it may not be available in other DBMS. Okay, yeah, many things like that. Yeah. That means when you need to do conversion, you need to do a lot of work. You need to search the document and study how to make the conversion. Okay, yeah. All right, so that's next question, number 7. When we insert an integer data piece for a table field in a SQL table, do we have to put in a pair of quotes around it? Yeah. Do we have to? Yeah. Question no, right? Yeah. Question no. Do we have to? Yeah. Here I just review a little bit. Yeah. For integer data, there are 2 options you can do. Okay. The first option, in quotes option. Quotes, you can do single quotes, double quotes. Yeah, both okay. Okay. Yeah. But single quotes better than double quotes. All right. Yeah. Single quotes better than double quotes. Why? The reason is simple. Single quotes, that's the SQL standard. Okay. Double quotes only for some of the DBMS. Okay. Yeah. It may not be supported by all DBMS. Yeah. So MySQL support that. Yeah. Some of DBMS. Okay. Yeah. That's the difference. Okay. Yeah. And another way, no quotes. Numerical data, we do not have to put them in quotes. Yeah. But here the question, which one is better? You have the quotes way, no quotes way. Which one is better? Now, here I want to explain. Yeah. No quotes way better. Okay. No quotes way better. Why? Yeah. Think about that. Yeah. Because my next question about string, you need to use quotes, right? Yeah. Here I include. Next question, question number 8. This time for string data piece. Yeah. Do we have to put in a pair of quotes? The answer is yes. Okay. All right. So when I talk about for integer data, no quotes better than quotes way. Yeah, we like to combine it with a string way. String only one way, quotes way. Okay, only one quotes way. Yeah. So here the case is, think about that. Yeah. When you use the no quotes way, you distinguish it with the string way, right? Yeah, no quotes way, string is not allowed to use that way. Only numeric value can use quotes or no quotes way. Yeah. So that means, yeah, if for some accident you put a wrong type there, yeah, no quotes way, yeah, but in case you put a non-string, non-numerical value, you will get error message. You need to fix it. All right. But if you use the quotes way, if you put some non-numerical value, you won't get alert, right? Because you can insert it. You can insert it. Even you insert non-numerical way, yeah. Sorry, that's not, yeah. Because when you do declaration, you already declare integer, right? Yeah. So then if you use the string, non-integer, even in quotes, you will get error. Yeah, you will get error. Yeah. All right. So here the one difference says, yeah. So based on my experience, I noticed, yeah, quotes way, non-quotes way. Yeah, quotes way useful in some special situation. It is useful. Yeah. Yeah. Especially you want to insert, when you write programs, you have both integer data, string data. Yeah, but sometimes you may not know which one integer, which one is string. That's possible. Yeah. Then you just use all quotes way. You can insert. Okay. Yeah. But if you know integer data, yeah, it's better to use the no quotes way. Yeah. In that way, you make sure you only insert valid integers. Yeah. All right. Yeah. Okay, so that's these two questions. Next one, number 6. Is it possible to use a SQL keyword as table field without causing any error? Answer is yes. Yeah, I explained in class. I use one example. I include one example. Remember, we use the symbol backstroke accent symbol. Yeah. If we have a keyword here, let's say keyword. Yeah. Let me use, suppose, for example, limit. Limit is a keyword, right? Yeah. In MySQL, limit is a keyword. But if I happen to have a table field called a limit, if I do not use this pair of special symbols around this limit, then I will get an error. Yeah, because limit cannot be used in this way. Yeah. So the MySQL will complain it. Yeah. But if I put a pair of backstroke accent symbols around this limit, then MySQL knows this should not be treated as a keyword. This is a literal name of a field. Yeah. In that way, it's okay. Okay. So that is this question. Yeah. Yeah. But not single quote. Yeah. Here you should not use that single quote. Okay. Yeah. The meaning is different. Yeah. Here there is a special meaning to escape the original keyword meaning. Yeah. All right. Number 10, is it possible to store the necessary information about an image for users to access without storing the binary data in the table of a database? Answer is yes. Yeah. Actually, the most commonly used way, we do not store binary data of images. We just store the URL locations of images. Yeah. So store URL locations of images. Yeah. Yeah. First, this part short, right? Yeah. Our image size could be pretty big. We know usually image size could be pretty big, relatively big. but URL pretty short. It's a string, less than 100 something characters. We can represent one big image. And images, they are stored on hard drive. Okay, hard drive, we have plenty of space. Hard drive of the server, here of the server, because we need to access from the server. Okay, hard drive of the server. Okay, then through those URLs, so the images retrieved from server and sent to the users. Okay, relatively small. Relatively slow, because you need to load images from hard drive of the servers, then send to the users with limited bandwidth, right? The bandwidth is limited. So you need to consider that bandwidth factor. So the image just could be sent in multiple times due to the bandwidth limitation. One trip not sufficient to send the whole image. You need multiple trips to send one relatively big image. And you may have multiple images. One page, you may have multiple images. Then you expect to get relatively slow loading time. Loading time. All right, so that's the background of this question. Quiz number 2, B.2. Question 1. When we have a database transaction, here, the transaction concept, that is formed by a sequence of queries, usually a sequence of queries to define a transaction. Okay, Are we allowed to execute this transaction partially? Main part is this partially. Answer is no. Answer is no, because in our database context, let me write DBMS context. This transaction meaning is different from our usual real world way transaction, the general real world transactions. Here in DBMS, sequence of queries should be executed in a special property, that property called atomicity. Atomicity property. Atomicity. This special terminology represent entire or none. Okay? You execute that sequence of queries in its entirety, completely, as a whole, or none. 0 or entirely, but not partially. Okay? Somewhere in the middle, partial. The reason is, in business, that whole sequence defines a critical task. That sequence defines a whole business task, or integral business task. You cannot break it. If you break it, you may have some severe consequence. We want to avoid that. Okay, so in business, this concept is important. Yeah, atomicity property. Here we emphasize that. Yeah, but later I try to show you some example of this transaction. Yeah, in Java, so we do a lot of transactions. We do our database queries in transactions. Yeah. So we need to set begin point. Yeah. When you start transaction, you set begin. Yeah. Begin, that's the beginning of the sequence of queries. Then you provide a list of queries. That's your sequence of queries. Then you have an end point. Okay, so there is a block of a transaction, end. All right, yeah. But this endpoint, we know in Java there is a try block, right? Try, catch. Oh, the try block. Yeah. Try block. Try is at the beginning. Try block. Okay, yeah. But catch exception, right? Catch exception. Except, yeah, here. Okay, some exception, yeah, catch, yeah. All right. When something is wrong, you are in this catch block, exception, all right? So roll back. Roll back to that begin point. Okay, that's the logic in Java. Roll back. Okay, yeah. So you do not execute partial queries. So you have to roll back. Undo, roll back, undo. Those partial queries. Yeah. Yeah. So in DBMS, for this part, it will do in a very careful way how to roll back, how do you undo it, right? In DBMS, yeah. So that part, so that's the reason the DBMS needs to do a lot of work to make sure this transaction concept is implemented, yeah, without causing any problem. Yeah. All right. Yeah. Question number 3, which of the following statements about the stored procedure, yeah, this is another big concept in DBMS, is correct? I spent a lot of time explaining the stored procedure. So what are those things we can do in a stored procedure? Yeah. But you need to look at some concrete examples. I didn't give you concrete examples in our class. I just talk about the general properties, but that's not enough. Yeah. You need to see concrete examples. Yeah. Here, we can do both, right? Locally, remotely. Locally, that means you work on the server machine of the DBMS directly. That's locally. Yeah. Remotely, you use the network, connect to that server. So you work remotely, and remotely also including you use application programs, including, so here, including through application program. programs. Yeah, okay, yeah. Yeah, and I need to give you examples for this part. We need to see concrete examples. Yeah, I have some examples. Yeah. Yeah. In this module, yeah, after we complete our review part, then I show you some examples. Stored procedures. Okay. Yeah. So in that way, first you need to look at the in DBMS, how do we define stored procedures? Using SQL commands. We can write a SQL function. Yeah. Procedure means function, right? Yeah. Okay. Basically SQL functions. Yeah. First, I'll give you several examples how to define stored procedures as SQL functions. Yeah. Yeah. So after you define that SQL functions as stored procedure, you just execute in your SQL command area. Yeah, we have a command window, command area. Yeah. Enter that as part of your schema. Yeah. So your database, you have a schema as part of your schema. Your schema will contain this definition of this procedure. Yeah. It goes to the schema. Okay. The definition of stored procedure goes to that schema. Okay. Yeah. All right. So then when you execute, just call that function. Call, yeah, the keyword call the name of your stored procedure. Function name. Yeah. Okay. With input or without input. Sometimes you may pass input data to it. Yeah. Function with parameters. Sometimes you do not pass input parameters. Yeah. So you just call, yeah, then execute. But that call, all right. So here I talk about call that procedure, call up stored procedure. All right. When you call, you can also call from an application program. How about that? Application program. Java or PHP. Yeah. Java or PHP. We just call. You just type in a pair of quotes, call the name of stored procedure, right? Execute. Then at the DBMS database server side, the whole procedure will be executed. And possibly it returns processing result to you. Okay. Yeah. All right. So I will find several examples to show you. Yeah. So let you see the concrete picture. So later, because this functionality is important. It's a powerful functionality. So if you know in some special situation, you can use this way. Yeah. It will be very helpful. Yeah. All right. Next, question number 5. Since the data redundancy problem would waste storage space and may cause inconsistent data, that's true. This part, no problem. All right, yeah. There is no reason, the conclusion part, no reason to allow any data redundancy in our database design. Conclusion part is wrong. Yeah. The first half sentence, that statement, that description, yeah, perfect, no problem. Okay, but the logic is even with that problem. Yeah. Here, yeah, sometimes, yeah, in our real life, when we use logic to make conclusions, sometimes the link may not be very solid. So here, the logical reasoning, this link is not quite right. Not quite right. Why? You provide some drawbacks. The drawbacks, that's fair. That's a fair description of the drawbacks. Okay? Fair description. All right? Yeah. The problem is with these drawbacks, do we mean this feature, you know, redundancy, data redundancy, this property, let's say property, this property is useless? We cannot say that, right? When you have some relatively big drawbacks, do you mean that kind of thing is useless? It's not, still useful, right? Even with, if something with some, you know, pretty significant drawbacks, yeah, that could be still could be useful, right? Yeah, in our real life experience, we don't throw away. Yeah, here we should not throw away. The question here is, yeah, we still use it because we want to have better performance. It's useful, still useful. Let me write this way. Still useful for better performance. Yeah. If we allow it, we can make the performance better, faster. Yeah. But we need to control that drawback, those drawbacks. That's why we call it control redundancy. Control the redundancy. Okay, the drawbacks should be controlled. Yeah. So that's why we have this concept called controlled redundancy. Okay. Yeah. So that's the logic. Yeah. All right. But usually I give questions like this. Yeah. I try to check your understanding. Yeah. If you really understand the whole concept. Okay. For some students, if they answer questions just by intuition, yeah, by tuition, without deep understanding, it's very likely, yeah, so then they select true, yeah, no problem, yeah, yeah, that's wrong. Okay, all right. Question number 6. Which of the following is the main purpose of the data denormalization? Yeah, so related to that control the redundancy concept, denormalization. Yeah. We add some control the redundancy. That's the denormalization, right? So what do you mean data denormalization? That's we intentionally add some controlled redundancy. In data. How about that? Okay. Add some controlled redundancy in data. Okay. Yeah. All right. Yeah. So remove, no, yeah. So definitely it's wrong, right? Save storage space. Yeah. Actually, we use more storage space, right? Yeah, not save. Yeah. Yeah. enforce the data consistency, enforce, actually it make the data make this part harder, right? When we add extra control, make this part harder, right? Make this harder. Because we need to do more work, right? With more redundancy, we need to do more work. Okay, make this part harder. Yeah, but with all the effort, extra work, we want to enjoy the last desired result, last one. We pay so much here, you can see we pay here and there, many places, quite expensive. Yeah, but we want to get something valuable, right? This last thing is the valuable thing we need. That's the valuable thing we pay, all right? Yeah. Improve the performance for data access with the controlled redundancy. Yeah. Okay, yeah. Try to understand. Yeah. All right. So that's these two questions of quiz number 2. Yeah. Question number 7. Yeah. All the data integrity constraints can be enforced by the modern RDBMS automatically. Yeah. There is one special thing. Yeah. We talk about, we have several types of data integrity constraints, right? Yeah, 1, 2, 3. Yeah. But the last one, the number 4, the last one, business rules. Business rules. DBMS cannot enforce business rules. Okay. RDBMS cannot enforce the business rules. Okay, yeah. That's our programmers. Yeah, probably programmers' responsibility. Okay. Programmer. We need to write the code. Okay. We can use many different ways, SQL statements or even stored procedures. It depends on how complicated those rules. Okay. Use either SQL statements. Yeah. But many times we need to use stored procedures. Okay. Yeah, because individual SQL statements, typically think about when you write a SQL statement, if you need to do many things, how can you do that? It's hard, right? Many things. Yeah. But in a stored procedure, then you can manipulate the data here and there. So yeah. Temporary data, intermediate data, move things around, do a lot of manipulation, and finally, you make sure all your business rules are enforced. So typically, yeah, you need to do a lot of programming in the stored procedure to enforce the business rules. Yeah. Here, I cannot give you an example. Yeah. If I can find a good example, yeah, that would be nice. Yeah. Okay. We can check, some specific business rules. We install the procedure too. Yeah. And the trigger, remember, yeah, I also talk about the trigger feature. Here, I didn't ask you trigger questions. Yeah, the reason is we have this concept, yeah, but it is not easy for me to make a trigger question. I thought about that a few times, but I couldn't find a good way to ask you trigger questions. Yeah, that's the hard part. Yeah. But I like to show you how to use trigger to, call stall procedures. When something happens, first you need to detect the problem, right? You need to find the violation of certain integrity constraints. After you detect it, trigger, you use that trigger to call stall the procedure. Okay, that means that kind of connection is automatic. Okay, you do not need to someone, supervise, monitor that activity. Yeah. You set up, you leave there. You do not need to worry about it. Just leave there. Then the whole thing will be checked, enforced automatically. So that's what you like to do. Everything automatic. Yeah. All right. Yeah. So this question, yeah. Let me see if I erase it. Yeah. Can we use SQL insertion? Yeah, that's easy, right? Insert multiple rows of data. Yeah. We know that's batch insertion concept. Batch insertion concept. How to do that batch insertion? Yeah, I describe it, comma separated. Between different rows, data of different rows, you use comma separated. All right? Yeah. So, and each row you put it in a pair of parentheses. Pair of parentheses, okay? A sequence of parentheses, but at the end, you close it with semicolon, okay? The end of the statement, still our usual semicolon, okay? Yeah. But we put a relatively large number of rows in one statement to improve efficiency. Because we only need to pay overhead part, preparation overhead part once, and we insert many rows at the same, not the same time, in sequential order, but sequential order, you only need to pay preparation cost once. Okay, yep. So that's the batch insertion concept. All right. That's quiz number 2. Last one, quiz number 3. Yeah. Yeah, I do not have a lot of time. Yeah, I only have pretty short time, 10 something minutes. Yeah. Let me see if I can complete it or not. Yeah, let me see if I have relatively hard questions. If not, we just continue next time. Every SQL table must have a primary key so as to be useful in the real world applications. Not must. So false. Yeah. Not must. Yeah. Although we like to have primary key, right? More convenient. We know primary key make our life easier, so we can identify rows easily, right? Yeah, we like to have, but remember, for table, when we define a table, we allow duplicate rows, right? Duplicate tuples. We allow that. With duplicate tuples, how can you have primary keys? Okay, primary keys, the basic requirement the key values must be unique. With duplicate tuples, how can you have unique key value? You cannot, right? Yeah. Yeah, but still, with duplicate tuples, that's useful data, so we allow it. Our, in the business environment, we allow it. Duplicate tuples. Yeah. All right. When we use the null value as a key, as a field value in a SQL table, we always mean that this value is unknown, but it exists. There are several cases, right? This is just one of the cases. Unknown, but exists. One of the cases. Okay. We have other cases, right? Yeah. For example, there is one case not applicable, right? That could happen. Not applicable, this field, that user not applicable. Okay, yeah. Yeah. For example, supervisor, right? For some employees, that supervisor field not applicable, right? Those employees, they are not supervisor, they are not any supervisor, right? So not applicable. Okay. Yeah, that's one of the cases. There is another case. Yeah, applicable, right? Value is known also. Yeah, but the value is very sensitive. Okay. Yeah. The company, as a business decision, the company does not want to expose those values in the table. Okay. In this database, they want to keep in a very secret location to protect, okay, to protect that kind of data. Yeah. So yeah, but they want to make people aware of it. Okay. So they put a null value. That's another case. Okay. At least the three cases. All right. Suppose that a SQL table does not have any key field. Yeah. Key field, right? When you see key field, unique values. Unique values, okay? Yeah. Is it possible for us to find a way to define a primary key for it? Yes, here. Look at this question. I check your understanding. If you pay attention to a special way to define primary key in a composite way. Composite primary key. I want to check you if you can connect to this concept. Yeah. All right. That if for some table, yeah, we have example in that university database, right? So if you look at a university database, sorry, we have that situation. Yeah, university. Okay, that database. There is a course table, right? Course table. We know in a course table, the course information listed as course and sessions, okay, sections, courses, right? But you can see courses are not unique. Section number also not unique. But if you combine the course number and the section number, then it's unique. Look at that. Course number, section number as a composite key, then it's unique. Course number itself, not unique. Okay? Yeah. Session number itself, not unique. All right. Yeah, but if you put them together as a composite key, It's unique, okay? Then you can use it as a primary key. How about that? Composite primary key, okay? So that's the background you can use to answer this question. All right, question number 10. All right, yeah, good. We have enough time, yeah, because I only select 4 questions from quiz 3, so we can complete it today. All right. There is no way that one can define a foreign key constraint with a circular reference. That means a foreign key in the SQL table refers to primary key of its own table. False, right? Yeah. Remember our employee table. Employee table used as e-copy, okay? And S supervisor copy, 2 copies, okay? In that one, 2 copies, we define a foreign key, circular reference, right? Yeah. It refers to itself, the primary key of its own table. Yeah. Yeah. But we can define it. But when we define the special way to define it, remember, how do we define it? You cannot define it directly, right? Yeah. You need to use the alter table statement. Yeah. Alter table statement. Okay. Alter table statement. The foreign key, which one refers to which one, yeah. The reason is simple, because after you define the foreign key constraint, the table already exists. Yeah. The table already exists, so you can refer to it. If you do not use this alter table statement, if you do it directly in your table definition, then the table does not exist. How can you refer to a non-exist table? Okay, non-existing table. You cannot refer to that. Okay, but we can solve that problem by this alter statement this way. Okay, yeah. So that's this background. Yeah. All right. Yeah. So here, that's another thing I need to do together with our new homework assignment number 2. We need to do quiz number 4. Look at that. Yeah, because we already complete module 4, right? Yeah. A few days, we start module 5, part A, part B today. Yeah. So we need to do quiz number 4 also this week. Yeah. So this week we will have homework number 2 and quiz number 4 this week. All right. So then next week, yeah, another week, yeah. So 2 plus 2, 2 days plus 2 weeks from today. All right, 2 plus 2 from today, yeah, for the midterm. Yeah. All right, so that's it. Let's stop right here.